Okay, well, just to make things a little more entertaining, we're going to make this one level trickier, and you might actually have to set up loops and stuff. But you have the concept. So what happens now, if I insert the resistor that I originally had here, okay? See, now what this is going to do is, okay, you see that I3 is going to be changing in time. Unless, as I said, unless this thing just happens to be designed to somehow balance what's going on over here. And you might think about how you would do that, but I wouldn't spend too much time on it right now. Well, that's going to affect your voltage drop across here, so you can no longer assume that you have a constant voltage drop. I mean, voltage drop across here and the voltage drop across here are still going to be the same, but that's going to change in time. Even if you have a constant source, that's going to change in time. Okay? So, what do you get there? What's your system of differential equations, and how can you understand it intuitively in terms of what's going on in the circuit? You got charge, flowing past here, flowing through here, so much charge in a small time. You got charge flowing through here, but here it's being transferred from one plate to the other, changing the voltage across the capacitor, right? And of course that's what causes the current to change generally. And then what happens if this thing's changing faster than this thing is? Because here we just assumed that this thing changes slowly enough that this thing, in a short time interval, the voltage drop doesn't change much, right? Okay? So you want to think through all that and then see how that relates to the equations.
Is R1 going to be the 10 ohms too?
You can let R1 be anything you like.
Okay.
I would go ahead and start off with R1 as 10 ohms. But then I would play around with the numbers. Once you have the analysis done, and actually the first thing I do is I do it in symbols. Okay? I gave you specific numbers here so you could grab on to specific numbers in your calculations and think about what they might mean. But now you have a pretty good idea what those symbols and so forth mean and how they work together, and the quantities you're going to be thinking in terms of. Okay? So you might just start with symbols and then ask yourself what happens if I play around with the relative sizes of these resistances.